Good day, everyone. Now, in this video, we'll be talking about interval notations. Yes, I know you've seen a lot of this and this. It's somehow quite confusing when the concept is not actually solid. Okay, so in this video, we'll be talking about getting the concept behind interval notations. Now, the first one we are going to be looking at is open interval notation. Now, the open interval notation is usually represented by a comma 0, right? And the difference between the open, close, and semi-open interval is this, right? So the difference in their brackets actually make the difference. That's not the only difference, but this is one of the difference. Now, this can also be expressed as a less than x, which is also less than b. Now, what does these two equivalent statements mean? Now, having a number line, right? A number line. Let me start from okay, let's 0, -1, and 1. Sorry, let me just add -2 and 2. Now, having the open interval, let's take -1, 2, right? Which can also be expressed as -1 less than x less than 2. Now, what we've written simply means that you are taking values which are actually let me say going this way, so let's write it this way, and also are actually this way. Now, what do I mean by this way? It means that values which are between the range -1 and 2. This means that -1 and 2 are not included. So values greater than -1, so if you're actually going this direction, so you can have -0.99999 going continuous, but -1 is actually not part, and this defines the open interval notation. So this can have a maximum value to actually 1.999 recurring without 2 being included. Do you get it? So now this defines the open interval notation. We are going to be taking more examples, but later let's please get the concept. Now let's talk about closed interval notation. Now the closed interval notation can also be defined with the square bracket a to b, right? Now similarly we can define closed intervals as a less than or equal to x, and of course less than or equal to b. Now maintaining and using this same number line which looks quite crooked, of course it's not drawn to scale. We can have, okay, so let's take the example -1 and 2 again, just as we use for the. Now this is just the opposite of the open interval. With this, we are taking values between the range -1, sorry, and 2, right? So all values within this range are considered, including -1 and also including 2. You get the point? So this can also be expressed as -1 less than or equal to x, which is less than or equal to 2. So all values between from -1 to 2 are taken under consideration for this, which is the closed interval notation. Now we are going to be talking about the semi-open interval, which is more interesting. Of course, as I said, this is more interesting. And why do I say that? Now we actually have two types of semi-open interval, as you might have guessed, because I have two number lines over here. And with the semi-open interval notation, we can define it this way. with closed on A and open on B, right? Now, if it's closed on A and open on B, now let's explain with another example. Let's take -1, 2 again. Now, this means that you are taking values from 1 and you go, and also values less than 2, right? So values from -1, which means -1 is included, but less than 2. Now, let me clear this quickly and let's define the second form of semi-open interval. So as you might have again guessed, or I think today you have to do a lot of guessing, we are taking values which is greater than 1. Now, why do I say greater than 1? Because it's in this range. So it would definitely be greater than 1 because you are moving towards the right, of a negative number. So greater than 1 but less than 2, right? And this can be expressed in the form -1 less than x, which is less or equal to 2, right? Hope you get this. Now we are going to be taking examples and we are going to be solving them as well. It's quite simple, especially when the principles are applied, right? Now let me clear this. Now we have the example. Suppose A is equal to the closed interval 0 to the open interval 2, and B is equal to the open interval 0 and the closed interval 2. Find A intersection B. Now the biggest mistake you can do first and foremost is writing the answer in this form: 0. Any answer in this form, if being asked in an interval manner, is wrong. Now why is this wrong? As we had on the number line, let's just take this example. An interval from a closed interval from 0 to 1, which can be written as -1, 1, doesn't only involve -1, 0 and 1, but it involves even decimals within this range, right? So -0.00001 is included in this range. Also 0.999 is included in this range. So therefore you can't write the answer in this form. Okay, now that was just by the way. Let me clear this quickly and let's continue. Now find A intersection B. Now it's most advisable to represent both of the expressions in a number line, right? So now we have, let's start from 0. So 0, 1, 2. Now on the closed interval 0, so we can represent the closed interval 0 as this straight line, right? And open interval 2 as this, right? Now B, let's draw our number line 0, 1 and 2. And the reason why we are using 0, 1 and 2 is because from observation we can clearly see that we have been given this in the numbers lie within the range of 0 to 2, right? So we don't have to label a number line to 10. It would be a waste of time. So on the open interval 0, we can represent it again with a straight line. Sorry, let me clear this. We can represent it by this because it's an open interval, and on a closed interval 2, so in this form. Now we are being asked to find A intersection B. Now please take note of this. We are finding all values which is present in A and also present in B. Now taking A for example, A consists of values ranging from 0 and less than 2, right? Now, B contains all values greater than 0 up to 2. This means that taking 0 and 0, the interval 0 to 0, for example, for B, 0 is not included, right? Which is included in A. And since we are finding the intersection, the the values must be both of our sets must contain equal values for it to be represented as an intersection, right? Therefore, you can just put this form as AB intersection B, and this will be equal to, let's quickly label our number line. And you're having an open interval, sorry, you're having a closed interval and an open interval. So of course, the open interval, sorry, would contain values which is not over here, right? So we can put this down for intersection, right? And similarly, we write a open interval, right? Now we can test this by saying in this range can actually fit into both A and B, right? So now you can write this inside of this, which will be this, and we can also write this in the form of this by just changing this expression, right? So this is a quick method in which you can test it. You don't have to get an intersection in which when you put it in one of the sets, it's like the intersection is actually greater than the set itself, right? So this is the first example. We'll be solving more examples in our subsequent videos. And thank you all for watching. This is Teach Me Math, and please subscribe. Thank you.